Critical path analysis, also known as critical path method, is a project management technique used to identify the sequence of tasks and activities that are critical to the completion of a project within a specified time frame. It helps project managers determine the shortest possible duration for completing a project and identify tasks that are most critical to its success. Here's a detailed explanation of critical path analysis. The critical path is the longest sequence of dependent tasks and activities in a project that determines the minimum duration required to complete the project. Critical path analysis involves identifying all tasks, determining their dependencies and durations, and calculating the total duration of the project based on the critical path. Each project is broken down into individual tasks and activities that need to be completed to achieve the project's objectives. Tasks may have dependencies on other tasks, meaning that they cannot start until certain preceding tasks are completed. Each task is assigned an estimated duration, which represents the amount of time required to complete the task. The critical path is the sequence of tasks that has the longest total duration, determining the minimum time required to complete the project. Process. Critical path analysis typically involves the following steps. Identify tasks. Identify all tasks and activities required to complete the project. This may involve breaking down the project scope into smaller, more manageable components. Sequence tasks. Determine the sequence of tasks and their dependencies. Identify which tasks must be completed before others can start. Estimate the duration required to complete each task. This can be based on historical data, expert judgment, or other estimation techniques. Create a network diagram or flowchart that illustrates the sequence of tasks, their dependencies, and their durations. Calculate the earliest start and finish times for each task based on its dependencies and durations. The earliest start time is the earliest time at which a task can begin, while the earliest finish time is the earliest time at which it can be completed. Calculate the latest start and finish times for each task based on the project's deadline or target completion date. The late start time is the latest time at which a task can begin without delaying the project, while the late finish time is the latest time at which it can be completed without delaying the project. Identify the sequence of tasks that have the same early and late start times, indicating that they are critical to the project's duration. Any delay in these tasks will result in a delay in the project's completion. Identify tasks that have float or slack, meaning that they can be delayed without delaying the project. These tasks are not critical to the project's duration, but may still be important for other reasons, such as resource constraints or stakeholder requirements. Continuously monitor the project's progress and update the critical path as tasks are completed or delayed. Adjust schedules and resources as needed to ensure that the project remains on track. Critical path analysis offers several benefits. Project managers can focus resources and attention on the tasks that are most critical to the project's success, ensuring that they are completed on time. Understanding the critical path helps project managers identify potential risks and vulnerabilities that could impact the project's duration. By mitigating risks on the critical path, they can minimize the likelihood of delays and disruptions. Critical path analysis helps project managers allocate resources more effectively by identifying tasks that are critical to the project's duration and prioritizing them accordingly. Critical path analysis provides a visual representation of the project's schedule and dependencies, facilitating communication and coordination among team members, stakeholders, and other project stakeholders. Critical path analysis has some limitations, including assumption of fixed durations. Critical path analysis assumes that task durations are fixed and deterministic, which may not always be the case in real-world projects. Critical path analysis assumes that tasks are independent of each other, which may not be true in complex projects with overlapping or interdependent tasks. Critical path analysis can become complex and time-consuming in large, complex projects with numerous tasks and dependencies. It may require specialized software and expertise to perform accurately. The critical path may change as project conditions change, such as delays in task completion or changes in project requirements. Project managers need to monitor and update the critical path regularly to reflect these changes accurately. Various project management software tools, such as Microsoft Project, Primavera P6, and Smartsheet, include features for critical path analysis. These tools automate the process of scheduling tasks, calculating dependencies, and identifying the critical path, making it easier for project managers to manage complex projects. In summary, critical path analysis is a valuable project management technique for identifying the sequence of tasks critical to a project's completion and determining the minimum duration required to complete the project. By understanding the critical path, project managers can optimize scheduling, allocate resources effectively, mitigate risks, and ensure successful project delivery.